Hello and good evening, everybody out there, to this 87th episode of Wissenschaft fürs Wohnzimmer, Science in the Living Room, as always presented by the Avis for Future, a group of people that work at the Alfred Wegener Institute for Polar Marine Research in Bremerhaven. My name is Bjorn, and I work at the Alfred Wegener Institute in the Bioeconomy Group and try to make the nutrition from tomorrow out of the ocean as sustainable as possible. And as always, I'm not alone, and I'm also really happy to have Hannah here with us, who will present herself in a bit. But first of all, don't forget, if you have any questions, please post them in the chat, and by the end of it, we will ask them to Hannah directly. And if you like it, leave some thumbs up or think about subscribing to the channel.
Yeah, thanks. I'm also here today. My name is Karina. I'm also working at the AVI. I'm a marine biologist, and I work on restoration of the once native European oyster to the German North Sea. And yeah, that's a species which builds reefs on the seafloor. So I'm especially excited today to see what other possibilities are out there and what Hannah can tell us. So, Stefan, you're up.
Thanks, Corinna. My name is Stefan Jurike. I'm also at the Alfred Wegener Institute and at the Jacobs University in Bremen. I'm a climate researcher and the ocean modeler. So I'm using computer simulations to predict how the ocean is changing under climate change or in general to better understand the ocean. So this also, I guess, some of the research that Hannah has done as a researcher as well is relevant to some of the things that I'm doing, but I will learn more about this right now. So I will hand over to Hannah to give her presentation.
I'm very happy to be here today. I would like to take you a little bit on a journey. It's a very personal journey. How I went along my passion for the ocean. How I developed a tiny bit about my scientific career. And then what I'm doing right now, because I'm not a scientist anymore, I sneaked in here. I'm actually founded a company, and I'll show you why, and also what it means that there's a lot of solutions out there, how to protect the oceans. So I show you by my first slide. So this is me diving. I'm a commercial diver already since 2006. I saw a lot under the water. I'm a scientific diver. That means that whenever you do science under the water, you need to have that certificate that you are allowed to go diving. And this enabled me to dive around the world and see a lot what is going on underneath the water. And I used it also for my own research. My big topic was always human impact on the oceans, and from toxicity to pollutions. I was specialized in coral reefs, so I was working around the globe in different tropical locations. And then in 2013, I started to think about a global company which combine environmental protection. And why is that? I saw while I was doing my research, I saw a lot of poor people around me which had like no possibility to change the situation. And I saw also a lot of corrupt governments. And I thought maybe we have to accept sometimes how the systems are, but we have to see how we can move forward from there. So I didn't want to have a NGO or something. I wanted to really build a company which has a large impact on the ocean and really change something on a global level. And while I was still doing my research, then finally in 2017, I made a big switch, and I founded PlanBlue, which was not my first startup idea. And yeah, since then I gave up my scientific career, which wasn't easy. And now I'm doing business. Yeah, so I'm starting now to show you a little bit about the current situation. I take you a little bit on the journey to look at the Earth and what we need to make things better, because there's a lot of destruction going on. And you can probably see a lot of talks where you can see yeah, what all things go wrong. But I hope when you see my presentation, you will get hope that we can really do something, and that it's now required to be very active and very smart to really make a change. So now you see here our globe, and it's quite amazing what we can see. We can zoom in any space on Earth, on land, in very high detail. Here I just did a screenshot of the Klimahaus in Bremerhaven, so I thought I'd take something everybody knows. And if you just look at the image, it's amazing. Like, you can see people strolling. I didn't even zoom in all the way, but you can see people strolling. You can see ships and what lays on the ships. We have so much detail. You can even see with some softwares how the streets are changing on millimeter level during the period of a day. We have a lot of data, but you also see on this screen areas where you cannot look inside. So you see here areas of water, and we're totally unaware what is underneath. If we zoom out now and look at our Earth again, we see that 2/3 of our planet is covered with water, and we do not know what lays beneath it. And when I talk about that, I mean not the topography of our ocean, but really what is there, what lives there, what is the biodiversity, what's really going on there. Also, yeah. So why is this actually the case? I mean, this is a really justified question. So we do have satellites which monitored already decades and gave this amazing data, which I just showed you. But there are no satellites underwater, and the satellites cannot reach into the water. Sometimes they can see a little bit, but when it comes deeper, there's absolutely no way we can have information. And it's very strange thing that we know more about the surface of Mars than we know about our own planet. So, and then the more strange is even that humans are highly dependent on the ocean. And what does it mean? So first you will know that the ocean means a food source for billions of people. That means that there's a lot of people around the world which rely on the ocean as a food source. Then, of course, it's a job provider. It's not for the fishing, but also for transportation and yeah, all kinds of jobs. And what also a lot of people forget, it's also a climate regulator. So it's really important for what kind of weather we have on land. And then we know a little bit what is going on. I'm quite happy about the awareness which were raised towards plastic pollution in the ocean. We are also working on that. I show you a little bit later what we're doing. But here you see an amazing image from the NASA. And yeah, one thing is plastic pollution, which we have huge trouble, which we also partly can't see because it all sinks down to the ocean, and what really floats is just a fraction of what is really in the ocean. But there's also a lot of pollution going on. Here you see very nicely the how the water, polluted water, goes into the, is merged into the coastal areas, and this runoff gets dispersed in the ocean. So we know that just from looking at that we have some issues there. And then, of course, and that is also a really big topic of the Alfred Wegener Institute, climate change, and this, for example, the sea ice. We have dramatic changes there over the past decades. And then something which is more hidden is that we have a very high biodiversity loss. So what does it mean? So when you have an ecosystem, you have like many species and they all interact together. Like coral reefs, for instance, they were developing over 2 million years. And therefore they're one of the most richest diversity on Earth. And is comparable, for example, for the rainforest on land. But we have a worldwide phenomenon that we have a big loss of species, and that is called biodiversity loss. And here I brought you a photo where you can see a little bit a difference between two reefs. One where you can't see so many fish, and you see also that on the left-hand side, where corals died off, and there's now a little layer of algae growing on the top. And then on the right, you see a more functioning coral reef, where you have a variety of different fish and corals. So we know punctually that there are huge losses in these ecosystems. But when you stand on the ocean and you just look out there, what can you really see? And we in PlanBlue, we really believe this is one of our major problems. Like, we were very dependent on the ocean, as we just saw. But on the same time, we know very little about that. And there are some statistics about it. I'm talking about 95% of like really is unknown. So that means we don't know what is growing there. And the 5% where we do know something about, we know very little about, because the way it's monitored, it's not it did not create comparable data. I will come back to that in a second. But important is that you see that this is very difficult to visualize the seafloor. And that is a very, very big problem, because the seafloor plays a key role in ocean conservation, and in the end of the day, because we are so dependent on it, on the survival of humanity. So we need to take care of these huge resources which can help us tackle major global problems, such as climate change, which I'm today have a little focus on. So we in PlanBlue, we really think, or you see that also above water, if you think about like how long it took that people accepted that we do have climate change, we have to see what is going on the water. And if you see what there's changes you can start to manage it. If you can visualize what is going on, then we can act on it and we can implement guidelines or even legal frameworks. But at the moment, this is not going on, and that is a really big problem. So one of our biggest hope when we grow in size, that's when the population grows, is the food coming from the ocean. So aquaculture. So the EU actually invests really large amounts of money in this section because they think that's the only way how we can, or it's the only hope how we can solve the demand of food in the future. But now, if you think about it, I don't know if you had the topic already, but aquaculture is actually a really large pollutant. So there's a lot of pollution going in the water, changing the ecosystem around it. And this is a really big trouble. So on the one side, we need it because we need the food. And on the other side, there's a pollution going on, but also we cannot regulate it. We were actually contacted from a Norwegian institute, and they have a problem that in the Norwegian fjords, there's a lot of aqua farms because it's good money if you can do their aqua farming because it's Norwegian salmon and it's famous around the world. So it's a really big business. But then if they have that there in the fjords, they get, they call it a bottom problem. That means that there's so much pollution going on that the seafloor is changing and that the natural salmon can't put their eggs there anymore and they don't hatch anymore. So it has a huge effect on the salmon. This is, of course, the government is very aware of this problem. But the thing is that they cannot manage it. They cannot provide guidelines because they cannot see what is going on the seafloor. Imagine we could look inside and we could, and the government, the Norwegian government could say, okay, this is allowed in 100 meters, this is allowed in 500 meters, this is allowed in 1,000 and 3,000 meters. And if this is the case, something happens. There's already great solutions out there how you can even get the pollution, how you can catch the pollution with algae or mussels. But they have no chance because it's just a tiny little bit more expensive. And so, the aqua farms are continuing the way they are there. So you see, if we would have the chance to look inside, we would be actually here there to manage. We would have a tool to manage this problem. And then my very favorite topic, and I really would like to draw your attention to that. And this is basically now the core of my talk here. The ocean is one of the best carbon sequencer we know. What does it mean? On the seafloor, CO2 can be fixed 20 times more efficient than on land. And that is very interesting for us because we have to get tons and tons of CO2 out of our atmosphere. And there's two possibilities. So one is that we restore ecosystems. That means now, for example, with dredging, the seafloor can be like a desert. The ecosystem cannot establish in a way they've been before because they get constantly disturbed. But on many, many places, and I'm talking about the area from 1.5 times the USA, the surface of USA, we could restore the ecosystem and sink gigatons of CO2. Another way how to do it is to have aqua farms with plants and then see how you can get it out of the system. We have partners which try to sink it in air, like grow algae and sink it into the ocean in areas where it gets buried and then be out of the system. So there's many great companies at the moment with stepping. But again, we have a huge problem because we need to determine how much CO2 is actually captured. Again, we lack of like an automated tool for this. And this is where we come in. Oh yeah, wait a second, almost. So what I think, or what we think in PlanBlue is that we really need a set of new eyes. Like we need to have the chance to see this kind and to detect this kind and collect this kind of data. Now I skip one scroll. So this is actually our technology, which we designed. We are a spin-off of the Max Planck Institute originally. So that's now a little bit longer, right? So it also doesn't look at all anymore. There's a lot of other features. But here you can see a plastic waste project we did with a famous NGO. I'm not supposed to say the name. But what are we actually doing what other cameras can't do? So yeah, I brought you a little example. So what we did is we developed the first underwater satellite to basically fill this data gap and pop up the seafloor in high detail. And what does it mean, high detail? So not topography, but really biodiversity or materials such as plastic waste. So how do we do that? We use advanced imaging, basically satellite technology. We put it in the underwater housing and we combine it with artificial intelligence and underwater navigation. And then all of a sudden we can pop up this, the seafloor here. On my example, you can see a car we scanned, and then you can put layers on the top where you are interested. So this is like a really simple layer. So here in red, you see the plastic, and in beige, I think that is where sediment is. And you can do that with many things, like for instance, indicator species, or or we hope, and that is my next slide, that we can illustrate how much carbon can be captured. So you see here a stitched image, and we call it orthophoto. And this is actually a seagrass meadow. And then with our special cameras, which take way more information than a normal RGB camera, we can visualize certain features which are of interest. I do have also some technical slides, so if somebody is like super interested about how it really works, you can ask me in our question session. So we've done many different projects. So we were involved in like restoration projects in Monaco, seagrass meadows in France. Then we scanned this underwater construction, like you saw for an example, the car. And already since 3 years, we're working intensively on plastic waste, and also the detection of different plastic materials. That is still ongoing. And now I just brought along some videos. This thing. So here you can see the underwater satellite. As at the moment it's dive operated, but this year we would like to mount it as a unit on different robotic AUVs. So That means, yeah, robots with can drive autonomously over the seabed. And it's not moving, I hope it does. So it's very easy. Maybe there's the one or the other diver. So it's very easy. Like you see here that there's a little screen and you can see if you scanned the area already. So as a diver, you can really be very, you basically don't miss out on different spots. And later we can do the entire map of the seafloor, and we can also georeference it. This is also really big trouble. So in the past, divers were jumping in the water, putting out transects, taking photos, then they had programs to upload it in their computer, had to click every single photo through, and had to, like, expert had to really look at the photos and analyze the photos, and then later they would have the data to analyze, basically do their statistics and then make their reports. And now with this device, you can capture the data, you capture a lot of data, and you can use it for different use cases. So it doesn't matter if you look for plastic, if you look for pollution, or if you look how much carbon is sequestered, you all have this data. And then with our AI, we can pick out what is of interest and make a layer on the top, and we can georeferences. And this is very important because if you don't know where you are, like, eventually you would like to know how our changes, what kind of changes are there over time. So it's very important that you know exactly the area that you can do that. So when I started as a scientist, I came to an island where I worked a lot, and I was diving along the entire coast, and I was looking here and there where the coral reef looked good and where the coral reef looked bad. And then I decided on some spots which looked like really extreme, and then I did my research. But actually, I talked then to some fishermen and some very old scientists who were also on the island, and they told me that they had to, just to access the ocean, they had to hack corals away, that they came behind, that they could reach actually the reef drop. And I was really surprised, and I also realized in that moment that, like, my pretty side were already degraded side. So in science, we call it shifting baseline. And this is really bad because over generations, we always have another feeling of what is healthy, a healthy seafloor, and what is a not healthy seafloor. So it's really fundamental that we get this kind of data, which we collect and store it, that also over generations to come, we can handle and we can manage what is the shifts which are going on the sea. So we really have a big job to do here. It's not necessary that we know everywhere in high detail what is going on. There are certain spots, we call it hotspots, which really reflect areas, how they are doing. And these are the ones we should start monitoring and save this data. So, and with this, I'm finished with my presentation, and I'm looking forward to questions if there's any.
Yes, thank you very much. We do have a question from the chat. It's a very general question, and it's about how large are the ocean areas where the light actually reaches the seafloor globally? So, because it's a lot of deep sea parts, but do you have an estimate how?
Yeah. Okay.
And before you answer that question, Hannah, thank you very, very much, first of all. And could you please unshare the screen, then we will all see you again.
Okay. Yeah, I don't know if there's technical thing, but I can just share them later.
I was about to say, yeah, we'll get back there.
Okay.
For the tech geeks.
Okay.
There you are.
All right. Yeah, first of all, I would like to mention that the technology is not light dependent. So you need good lamps, and then you can go anywhere. So the technology doesn't need to have light. I think that is really important. And the other question of like how much light, it's like really like there is a called euphotic zone, which goes 200 meters down, and this is how the light can travel. But it also depends how much disturbance and also how little particles are above water. So it's even if you would calculate, this would be a very, very difficult very, very difficult to even model how much area that would be. But I think it was more towards like the technology. So that doesn't matter. You can go at the deepest place. You just have to bring good light, and then you can get your data.
Yeah, that's very interesting because yeah, we work in the North Sea. So for me personally, and we have all those particles in the water. So sometimes we really have to go like as much as we can down to the seafloor. So can this be a problem? Like that?
Of course.
Just the
yeah.
height.
We are working visual. So and the North Sea has a lot of like little particles. I mean, the ecosystem relies on the little particles. This is how everything works, and this big ecosystem gets their food. So that's of course a big issue. But then there's two possibilities. So in some areas you have a lot of turbidity. So that is that means that there's a lot of particles in the water column. But then you can see how you can solve that with season. And in principle, it's also possible to build clearing chambers. We didn't look into it. So for example, in the harbor area, when you want to work or something, it's already used for cameras that you can still see, because the harbor is also catastrophic when it comes to visibility. So there are some possibility how to solve that. But that's of course not an easy task. So you have to see how you can solve that. But again, we don't have to like cover everything, and maybe in some areas we cannot do it at all. But it's important that we still have this kind of data, and that we get as much as we can and save it.
That's true. Thank you.
There's actually, thanks for the talk. There's actually a follow-up question from the same person, from Stollentroll Ace. How well does the referencing underwater work? As the water absorbs the electromagnetic signals from GPS, how are you planning to achieve that?
Yeah,
this is especially if you're deep down in the water, right?
No, that's always the case. In the water, there's no GPS positioning. So GPS means that georeference system. So when you have your mobile phone and you walk, then you actually need 3 satellites to get a good positioning. And that's only possible in air. If you submerge something, then you don't have anything of the data. So you need a set of different sensors. So we have actually 5 different ones included in our system. So we take, before we submerge, we take this position, and then we don't work anymore with the satellite positioning. We work with our own positions, but it's really tricky to do. And it's one thing of our IP that this is alone to combine video image with this kind of underwater navigation is already very revolutionary at the moment, because we still, like, when it comes to technology under the water, we really like kind of in the Stone Age. This is a good question.
And then maybe just ask, so basically one of the assets of your company is then to actually develop these technologies, right? And to further develop the ideas that are necessary for observing the ocean floor.
So what we do is we buy off-the-shelf components, like from space technology and everywhere. We put them in an underwater housing, and then the way we combine things, and the way we extract data and process data, this is the core of what we're doing. So the hardware is, if you look at the entire company of us, then the hardware is a tiny part in the beginning. Yeah.
Thank you, Hannah. So there's more questions coming in. I see here from Israel Medina. What is the potential to use alarming cover loss throughout the world? What is the potential to use this device to sample seagrass areas and tackle the alarming cover loss throughout the world's coastal areas?
This is exactly, we actually, at the moment, I try to get in some additional fund, especially to solve this issue. We need to really invest in that to make that work, that we see the how much carbon is captured. And then also that just monitoring over time, that is like a standard, a standard for what we want to monitor, like if how the seekers, you can even show with this device, because we use, now I say it, hyperspectral imaging. You can even see the health stage of the seafloor, because you you can also, for instance, when you screen coral reefs, you can visualize coral disease with it. So it's a really great device. I mean, you have to program it, and the machine learning has to learn what it has to look at. But in principle, you can train it all kinds of things. And with the seagrass meadows, they're really important. They're one of the best CO2 capture, and also for like other climate-related gases. This is fantastic. And yeah, that is exactly what we want to do. The seagrass meadows. We also look how we can maybe upscale our data, so that will be also in future coming. So what can you do? Like, can you use satellite data to like you know, when you have the detail that you can, and use satellite data again and combine this technology. Also, there are bathymetrical methods, so they don't really show what is out there, but they give you an image. So we also have to see how we can combine technologies over the next years to make it more efficient, especially when you come to really large areas. Or what I'm dreaming of, that we have fleets of underwater satellites, and that they just get crazy data in a short time period of a big areas of the seafloor.
I mean, when Elon Musk gets all those Starlinks up there, why can't you get those ones down there?
Exactly. No,
Made it Bremen.
I think also I mean, it's a bit sad, but also I think within the next decade, we will see a lot of shift in our climate. I mean, we now have like storm events where you think like, oh, is this normal? And there will be more coming, and especially in the poorer countries, they feel it already now even more. So yeah. I think there will be a lot of focus, and if you really look into, for instance, the Green Deal, this is like a declaration of the EU. If you really look into it, like everybody gets more and more aware that the only chance we have is to take care of our oceans. And I also personally think that's the only chance we have to really get out of it. There's no way around it. We have to acknowledge that, and we have to make the effort to get the information and really start working on changing things and enabling also sustainable technology development.
And management, as you said, management, as you said, because you can't manage what you can't see. I think that's what you made very nicely clear also in your talk. But I know that Corinna has a question on seagrass meadows as well, I think.
Yes, I do. Yeah, because I think it is a really important question, and every country everywhere should really look at where the blue carbon is stored and protect this. But for Seegras in special, because it is so important, I was wondering, when you calculate the carbon sequestration rates, for example, or the stocks, it is very regional, right, for seagrass meadows or any ecosystem. So do you do additional research? So on top of the imaging itself, do you take cores or anything? Because I just know that it's very different in the Mediterranean than in the North Sea, or coral reefs, of course, are in warm temperature, the sea, so that's very different. So do you work with researchers there, or how do you calculate it?
Yeah, if there are researchers, we do write a big proposal exactly in that direction. But it's also trivial. Like, you need, if you want to become a standard and a certified standard, you need to work together with certifying bodies. So we are actually now in talks with those certifying bodies. And it's an entire process, because you really have to prove also within research frameworks, like with scientists and publication, that this works. But I mean, it has been done a lot of times, like in a very basic way, and we can deliver much more information. So, but of course you need, it's called proxy. So you have to make this proxy that you can do this kind of estimations. And it has to be in such a way that it's really certified and
Okay, great. Very interesting.
Yeah, I'm also quite excited, because when I came out of science, like, I saw all this destruction around the world, and I started to give public talks, because I couldn't handle it so well to see that. Also, one coral reef I saw basically falling apart within 3 years, and it was always so sad. So I also thought, oh, this is so sad. I just tell people how it all goes down. And now I'm in these entrepreneurial scenes, and we are in a lot of accelerator where there's only sustainable companies. And I'm telling you, like, really awesome sustainable companies, like big problems, a great solution, but difficult with the market. And I must say, because I experienced this, is so great for my heart to really see, like, okay, it's really bad out there, but there's also really, really good solutions out there, and they're there. And if we see the value of this kind of data, if we start like having an industry with carbon sequestration, for instance, if we can enable this entire industry, there's so much to do. And also the examples I talk with the aquaculture, yes, they pollute a lot, but you can do so many things more. And those great solutions that usually don't have so much a chance, because there is no niche in the market where they can establish. So it's really on us and our behavior that we can change that. And there are the solutions. So a lot of people get pessimistic, but if you just look around, like there's, for instance, one accelerator, they're called Climate Kick, and just look at the portfolio. So this is a European accelerator. Accelerators are programs where they pick out of many some startups which they think are really relevant to their specific topic, and then they like heavily support them. It can be financially, it can be information, it can be investors, and and we were one which is a European one which focus on climate change, and they call it Climate Kick. And it's so nice if you're like pessimistic, if there's some researchers out there who is like looking how the world goes down, like just look at it, because you will get positive again and you start fighting for really a change.
It's very nice. I think for all three of us, that's really nice to hear. As scientists, this is exactly the problem that you often have. You see all this stuff and then you don't know what to do with it because nothing changes. So it's good to know that there is the active part out there as well. Which brings me to my question, actually. Oh, one thing I wanted to say, we actually do have talks about aquaculture and how this needs to be adjusted to make it more sustainable and how to take care of the pollution and things. So there is stuff in our channel if you're interested in that. But my question would actually be, so this seems, at the moment at least, seems a very time-consuming task, right? If you have to dive and scan the ocean floor. So how large areas can you actually scan at the moment? I guess you as you said, you want to upscale this with automated satellites underwater and things, but at the moment, how difficult is it to sort of investigate a specific area?
Mm. So one thing I would like to make clear, so we still like developing. So we have like several prototypes and things like that. So you can do like at the moment, the divers really restricting the area. So that means, of course, also, I don't know if you are a diver, but the deeper, the shorter, the shallower, the longer, because of your water yeah. So it's not straightforward to answer, but you also need to see it in a relation that like people, what I said, like a group jumps in, transects, take photos, and then also the process just to look at the photos, like that the expert looks through, takes over half a year. So in half a year you get get the data, and that's also like the time to data. That's really relevant because you can do so much if you immediately know what's going on, and so you like. What you can do with a transect, like we are 1,000,000 times faster than taking some photo because you just have to swim along. So if you compare that, it's already amazing. And then we have to see what we can do with underwater robotics. And I'm quite excited. Yeah, they have, of course, much larger areas they can cover. That's why I cannot tell you now exactly, as I said.
I think that's the meaning of a startup, right? You're still at the beginning phase where you try out things and where you have to adjust to this, right?
Yeah, I mean, we are now since 2017, so we're also, the technology was developed since 2010. So there's quite a lot of know-how already in the device. But of course, there's so many things to do, and also the application, if you really want to have a device that captures all the data, that you can always pick the sand grain of the information you want. You have to be really, you have to develop a lot, need a lot of million before you can scale. But we plan to do that in 2 years.
Thank you, Hannah. So there's one last question that we take from the chat. And
sorry.
Don't have a zip. No worries. From Dirk Weich from South Africa. Could you give an example of the solution that came from data collected, please? That's what he's asking, about the solution of the data resolution that you have, I assume.
You mean for the industry? Oh yeah, we cannot ask back.
If you can clarify that question, please do so. What you mean exactly about the solution? Maybe he means resolution.
No, I think as far as I read it, it really is like, did anything develop from the data that you provided? So did they come to solutions for specific areas, or how to deal with plastic or with seagrass or something? Is there already something where you can basically tell a success story? That's how I read it.
Okay, that would link also to the question that I have, maybe that you could touch upon. As you were talking so much about coastal areas, obviously, because also the restrictions that you said currently, if you have a diver that you send down. I just recently submitted a project that also encompassed ecosystem-based management to artisanal coastal fisheries. Do you see applications there, or taking Dirk's question of what solutions do you also maybe have for coastal communities when it comes to better management of aquaculture fisheries, so to take but at a reasonable scale so that both can thrive, that is the coastal rural areas and also the ecosystem?
So we are a startup, so that means also that we need to have customers who send us in areas. So we're not at that stage where we can just randomly go somewhere because we think it's an interesting area. We look already in there. It's what we want to do is really also to define hotspots, like area, for instance, which are important for climate change, and then start scanning and then selling the data to different stakeholders. Like that is the an idea, but that will be way later. And then maybe to the question from South Africa, I'm surprised that it's reached so far. I'm very happy about that. So each customer has like a question we then answer. So that in our restoration project, it was like how, what kind of biodiversity develops. Then we had NASA EPSCoR project where they were interested in how the climate affects different areas. Then the one in the Dominican Republic that was all about plastic waste and their monitoring. So they have basically they know that in the rivers there's a lot of like plastic pollution coming from, and they deployed you know then which NGO, but it doesn't matter. They deployed their mechanism to like catch basically that, and then they wanted to see if that is successful or not. And also when they clean areas, if that has an effect on the ecosystem. And that was answered then with the question. So at the moment it's like a customer, and then we see how we solve it. And then of course with the carbon sequestration industry, you need to have the standard, and this procedure takes 2 years. So we are already like actively engaging in that, and that is maybe a better example where you say, okay, you develop a method like algorithm which show you what you want to see, and then you can serve like a lot of industry. But there's also offshore the whole offshore business or the wind parks. There will be big shifts in the future. There's a lot of hope that we can get our energy from there. But then at the moment they try to do a lot of with technologies with a lot of ultrasounds. So you can, this technology or our technology is visual, so it doesn't pollute with noise. So I think also there we wanted to have maybe first quick solution, but now we should really think what are sustainable solutions to monitor underwater construction. That would be maybe another example where you can like offer alternatives.
Right. Thank you so much, Anna. It was great to have you here and seeing you after such a long time now as a businesswoman. Really nice. As we mentioned it, or Stefan mentioned it, so I personally said something about aquaculture in episode 3 that was back. I just checked on the 30th of April 2021. So then you understand a bit more about that. I find it really interesting, also potential application, how to use that technology in the vicinity in order to change management and do it better. As I said, that's part of my job at RV to kind of try to solve some of those issues that you mentioned. And then you also mentioned carbon sequestration from algae. That was actually an English-speaking episode with Mar Fernandez that also joined RV now. That was 58. So that would be also interesting for some of you that might be interested in that. Other than that, next week, of course, there's a next episode that will be German-speaking, and it will be about forest and climate. And Janos from the Umweltforschungszentrum in Leipzig will tell us a bit more about that. until then, thank you so much for staying with us. Hannah, thank you for being with us today and for this great talk and visualization of what you're doing. Super interesting. We have many more questions, maybe after this. So thanks to all of you. And I think this is the right sign for today. And yeah, peace to all of us. Bye-bye.
Bye.
Bye.
Wissenschaft ist